Okay, in this video we're going to take a look at stresses in a pressurized cylinder, and we looked at the nomenclature last time, and we looked at the stress situation in class on Friday evening, and we saw the equations for tangential stresses and radial stresses, and we defined those terms, and let's see, we have them for the more general case, and we have the stress state for which we only have an internal pressure. And so slightly simpler equations. We also have the possibility of thin walls where the stress is presumed not to vary through the wall thickness. It does vary, but it's presumed not to. And we also then have a longitudinal stress. So let's take a look at an example. We have an aluminum alloy pressure vessel that's made from tubing, have an outside diameter of 8 inches and a 1/4 inch wall thickness. What pressure can it carry if the permissible tangential stress is 12 kpsi and the 30 for thin-walled vessels is assumed to apply? So we're going to calculate the pressure versus stress based on thin wall assumption. Then once we find that pressure, we're going to come back and on the basis of pressure, compute all the stress components using the theory for a thick wall cylinder. And so here we have our, it says D inner is 8 minus 2 wall thicknesses. And we have an R inner, we have et cetera, et cetera. And so now we can go to our formula that relates pressure and sigma max in the tangential direction. Let's just jump back to that. And what we have is sigma max is a function of pressure. We can invert that, of course, by moving these terms to the other side. So 2t in the numerator, di plus t in the denominator, 2t in the numerator. Plug in all of the numbers, 774 psi of pressure. And we can also calculate the longitudinal stress from our equation given right here. Okay, and we come up with a 5,800 psi of longitudinal stress. So the longitudinal stress is actually worse than our, I'm sorry, that's a pressure. Longitudinal stress is about half of our tangential stress. Okay, now we're going to turn to thick wall theory and say that we have a maximum tangential stress that will occur on the inside radius. So we're going to use R equal R sub I in this equation, which you can drop back a couple pages in the notes. And this is our maximum tangential stress occurs when R, which was down in this denominator, unspecified, when R becomes R sub I. Plug in all the numbers, and we get 12,000 psi for that pressure. Now let's see, let's go back and remember what our limits were. Okay, 12 kpsi was our presumed stress level. And so it looks like for this one we're matching pretty well. We got a stress of 12,000 psi for that pressure. So thick wall and thin wall worst case stress actually match very well. Okay, the maximum radial stress on that inner wall is, of course, the pressure. So sigma radial is simply the pressure, and that's pretty low, 774 psi. Then our longitudinal stress can be calculated for a thick wall cylinder. We can go back to equation 3-51, and we get a 5620 longitudinal stress. Let's see, what did we get for the longitudinal stress of the thin wall cylinder? Right here, 5810 compared to 5620. Now, of course, what we have is three different sigmas acting on this thing. We have a tangential, we have a radial, and we have a longitudinal. Now, there are no shear stresses acting in this particular thick wall cylinder. We don't have any torsion, we don't have any VQ over IB bending or any of that. So our stress state would be simply 3 sigmas, and these are our 3 principal stresses since there were no shear stresses. And so taking a look at the stress state, we could draw our stress elements. Now, if we were worried about maximum shear, we would only have a little bit to worry about because our sigmas 1s, 2s, and 3s in order would be sigma 1, farthest to the right, sigma 2, sigma 3 being a little bit to the left. It means our maximum shear stress is going to be based on a diameter that spans these 2 points, which will be a little bit more than just half of the 12,000 because of this fairly small radial stress. So even so, we would want to think about all 3 Mohr circles that might come from these if we're worried about a maximum shear stress theory. And that's all for this video.